Let's just get straight to the printing. Someone left a comment on my last video saying to adjust the belt tension to see if I can get the printer to make less noise. See if I tighten this up, I get even more resonance and more noise. But if I loosen it, it quiets down quite a bit. Both of these prints came detached from the bed before they finished, but I've got enough here to see if it works. So I've melted it together using a torch, and we'll see if it can split some wood. Well, that worked all right. Next test is to see if it can split a brick. Oh yeah! The tip is a little worse for wear, but if I made a blunt tool, like a sledgehammer or something, I'm pretty sure it would be effective. Since both of my last prints failed due to warping, I think now would be a great time to try out this enclosure. People don't usually talk about printing PLA in an enclosure, but when you're printing super thick parts like this, there's tons of thermal stresses that cause your parts to warp, so we'll see if this enclosure helps with that. Assembly instructions, we don't need that. The packaging here is really nice. So I'll start by undoing these 4 screws so I can separate these 2 pieces. These appear to be the top and bottom of the enclosure. We've got 4 aluminum extrusions, which should make up the corners of the machine. It comes with these little copper bushings, and you're going to want to put some where the door hinges are going to go. So there's 2 on the bottom piece here, and there's 2 on the top piece. Then I'll install the fan over here. It seems that these screws just thread directly into the plastic, which is a nice low-cost solution. Then you can take the included filter pack and put it on top. Next up, I need to install the pillars into the bottom and insert 1 screw under each corner and thread on one of these supports. It looks like these pillars are identical and symmetric, so that makes assembly a lot easier because you don't have to pay attention to where you're installing them. I'm torquing these bolts down until they're flush with the bottom. They kind of sink into this foam board material. Once all your bolts are installed, they include some padded feet. Attach one of these sticky feet onto the bottom of all 4 corners. Next, you're going to want to install all 4 sides of the enclosure. When you remove the plastic protection, these sides are nice and clear. The fan's going to go on the right side. The logo is going to go on the back wall. And there's only 1 side left, so you know where the last panel goes. Now those brass bushings that you inserted earlier, now you're going to put the door into these copper bushings that you installed earlier. The last step is to install the top. You're going to want to make sure to line up these bushings so the doors are held in place properly. Then put the 4 screws in the top here, and you're going to want to gently prod everything to get it to fall into the slots that are cut in the top. And it just fell into place, so everything should be aligned now. And just like on the bottom, I'm going to tighten down these screws until they're flush with the surface. Alright, and just like that, we have a little terrarium for our 3D printer to live in. Fnatr, or I don't know, that's kind of a strange name. Fnatr. Fnatr. I'm going to call it Fnatr, okay? Fnatr did warn me that this wouldn't fit the Ender 3S1. This enclosure is designed for the Ender 3 V2 series of printer. So you can see this just barely doesn't fit. It's really close though. But I'm not going to let a little setback like this get in my way. I'm going to remove these pesky feet on the Ender 3S1. We don't need those rubber feet. Oh wait, we do need those. Without those rubber feet, the fans are going to be blocked when it sits on the bottom there. When I removed this foot, I found this strange loose bolt under here, and it's right next to all the high voltage stuff on the power supply, which is kind of worrisome. But I'm just going to go ahead and put this foot back on. Pretend we didn't see that. Alright, let's get this fatty out of here. You don't fit, do ya? Let's see if our Ender 3 V2 fits in here. Yep, that fits in there just fine. The doors close. So as you can see here, the bed can move all the way forwards and backwards, and the doors can close. So this is definitely designed for the Ender 3 V2 and previous printers. The Ender 3 S1 grew a little bit, which I don't think Fnatr was counting on, so they'll be releasing another version of this printer box that you can fit your Ender 3 S1 into. Hopefully I'll be able to review that when it comes out. As you can see in here, the Ender 3 V2 fits nicely. In the meantime, you can buy this one on Amazon. It's about $200, which I think is a pretty good deal because I looked into buying some of these plexiglass side panels to make my own enclosure, and they're pretty expensive. So getting this pre-built kit ends up costing about the same, and it has a lot more professional look to it. But we're not doing a video on the Ender 3 V2 right now, so let's just take this out. And we'll see what we need to do to get this Ender 3 S1 to fit. I just need to cut out a hole that's about the same size as the Ender 3 S1. Also, I want to get rid of this stupid handle in the front that sticks out. Nobody asked for this Creality. So that made the printer a little bit shorter in this direction. I'm going to cut an Ender 3 S1 shaped hole in the bottom here. I'm going to mark where I need to cut along the front and the back. And since this is flipped upside down, I'm going to take the offset that I need over here and draw it on the opposite side. And I'm going to take the offset that I need on this side and draw it on the other side. Then I just got to drill some holes. Then I'm going to play connect the dots with this hacksaw blade. Actually, I might be able to do a better job with this tiny knife. This foam board stuff is stronger than it seems like it would be. I almost need some woodworking tools to get through it. Now there's probably a bunch of better tools for the job, but this is what I've got to work with. So here we go. Actually, that was a terrible idea. I'm just going to use a Dremel here. This stuff's pretty strong. It's about as strong as wood, so not bad. It seems like there's enough strength left over that the structure of this thing is fine. You can see the Ender 3 S1 fits in here almost perfectly now after the addition of that hole in the bottom. Acrylic is kind of difficult to work with. It can shatter if you're not careful. So I'm going to be using this torch to melt a hole here. Okay, now we're ready to print with our enclosure. So we'll see if our warping performance is any better. You can see I've got two sets of lights here now. One of these lights is from the Fnatr Enclosure, and the other one is from the Ender 3 S1 Pro. Now this Fnatr Enclosure one is held in just with a friction fit, so if you find that it's loose and falls out like this, just use some thin material like this paper to shim it, and then shove it back in. Then it should stay in place quite a bit better. Now I'm going to turn this machine on. I've bypassed the filament runout detector by putting a piece of filament in it, and I'm feeding filament in through the top hole right here. I don't have a spool holder, it's just going to sit like this and pull the filament in as it needs it. Looks like everything works. I'm going to tell the printer to heat up. All the heaters in here will get up to temperature, and we'll watch the temperature rise on this thing to see how hot this enclosure gets when the printer's just running. At the beginning of this test, we're currently at 72.6 degrees Fahrenheit. Now we're at 81.5, so that's about a 10 degree Fahrenheit difference, or 6 degrees Celsius. I could throw a blanket over this thing to help it get even hotter, but that's a bit too much of a fire hazard for my taste. In addition to this temperature increase, you're also preventing drafts from blowing by and cooling your parts off. Your household ventilation system, blowing just a tiny amount of air across the parts, is going to cool them down a lot. You're really helping reduce warping on your parts. I'm going to start up that same hatchet print that fell off due to warping last time. So we'll see if this enclosure helps and prevents warping on this print. Now we're printing closer to 48 cubic millimeters per second, and we'll see if we get better print quality. Also, I don't have a spool holder up here, I've just got the spool feeding directly into a hole, and it's just spinning and dancing around right now. It's kind of fun to watch. So this is about to break off. You can see the handles lifting off at this end. And that just has to do with the thermal contraction that happens. Basically, as you lay successive layers onto the part, they shrink until it eventually pops off the heated bed. So I'm going to cancel this one. I've got another strategy that I want to try out. Basically, I'm just going to print this thing in 5 layers, with each layer being completely massive. So hopefully it can finish the print job and keep everything molten enough that I don't have those issues with everything shrinking up. Alright, here we go. Let's see if this works. I think the printer has got confused. It should definitely be going faster than this. I'm expecting it to speed up any minute now. I think we ran into some kind of limitation with the firmware. It just doesn't want to make an extrusion move that's this big and this fast. So it decided to slow itself down. Okay, I'm almost done with this project. I just have to put my new axe head into my new handle. The print job's finished on both of these. On this one there was a bit of curling. This end picked up off of the print bed, so you can see it's kind of curved there. I had a little accident with the Dremel, but fortunately I'll be okay. I've developed thick skin by reading my YouTube comments section, so I think I'm going to be alright. So this is just going to go in like this. I'm going to fully melt this thing. I'm going to completely melt the heck out of it. So here goes. Alright, there we go. It's all finished. Now what am I going to do with this thing? I'm going to show you how to flame polish these parts. So basically just take a fire like this and heat it up. And that looks a lot nicer. It got rid of the printed texture and you're left with like a shiny, kind of bubbly texture. That's pretty cool. Now it's all shiny. That's an interesting look. It's definitely a good way to hide the layer lines. Alright, so that about wraps up this video. I'm not sure what the point of it was, but I made a hatchet. That's pretty cool. I think I'm going to keep this hatchet around for my future unboxing videos. So next time I need to open a box, I can just... It's kind of fun making this too. I can see why people are into cosplay and printing out all sorts of random stuff. This melted joint actually ended up being super strong, so that's a nice reliable way to join plastic parts together. It's basically welded together now and it's just one piece. It's also fun to experiment with flame polishing. This is nice and reflective and shiny. It's a completely different surface finish. It kind of looks like it was spray painted. I really like this Fnatr box that I tried out. It looks really classy and it's effective at holding the heat in. Hopefully they'll forgive me for hacking this to pieces, but I think I proved that this box is pretty darn strong. After cutting a gigantic hole in the bottom, it still held together. Just make sure to get the right size for your 3D printer. At the time that I'm filming this, they don't have a model that fits the Ender 3S1, but they should be releasing one pretty soon, and I'll be doing a dedicated review on it when that comes out. I'll leave links to all the products that I tried out in this video, including the Mosquito Magnum hot end and this enclosure. And well, that's about it.